Right, so one of the things that we did before in one of our earlier videos is something we're going to do now, and it's something that you definitely have to be able to do. So if you're given a radical expression, so you have a radical sign, you need to be able to rewrite that as an exponent, meaning that you have something raised to a power, and as a rational exponent, meaning that we have a fraction as our power. So some problems, just like the adding subtracting one we did before, where it looked like you couldn't do anything with it, some of these problems, they may look like you can't do anything, but when you rewrite them either out of a radical and as a rational exponent, then you can, and vice versa. So you just need to be able to rewrite from one form to the other. And remember, here we have a radical, and here we have a radicand. So I'll just put an x, and if it has a power, and then this is our index. So remember, if we want to rewrite this, whatever we have as our radicand is our base. So it's what's being raised to the power. And then our rule is we will have a rational exponent, meaning we'll have a fraction. And it's power over index. So here we would say, okay, our power is 3. Our index, it's not there, so it's understood to be 2. So this is equal to x cubed over 2, right? So you would need to be able to start as a radical and rewrite it, and then you also need to be able to go backwards. So if you're given a rational exponent and you need to rewrite it as a radical, you would say, all right, well, it's power over index. Our power is 3, our index is 2, so it will be x cubed, or the square root of x cubed. All right, so you need to be able to go both ways. And the reason here it says if m is negative, then a cannot equal to 0, because you can't, if a was equal to 0 and m was negative, so 0 to negative 2, this is equal to 1 over 0 squared, and you can't have 0 in your denominator. So if our power is negative, it can't be 0. All right, and then we just have one example or a couple examples that we're going to do with this. All right, so for this first one, if you have 216 raised to the 1/3 power, now it might confuse you with the way it's written here. So what you can do is just rewrite this as a radical, so it's something that's a little bit easier for you to see. So here we have 1 over 3, and remember it's power over index. So here our power is 1, so I can write the radical sign. I can write 216 now. I can write the power like this, or I can rewrite it like this. It does not matter. It does not matter if it's on the outside or the inside. It's the same. All right, and then it's power over index. So my index is 3, so these are both the cubed root. So now looking at this, you would say, oh, okay, it's a cubed root of 216, which if you're not sure what it is, you can go ahead and plug it into your calculator. Or if you know what the cubed root of 216, we know that the cubed root of 216 is 6. All right, so a number that might have looked really hard for you to solve, 216 raised to the 1/3 power, is actually quite easy if you just convert it to a radical. Here we're going to do it 2 ways. So the first way I'll do it in black. So here we have the same base. We have both of our numbers that are being raised to a power 7, so we can just add our fractions. So 7 to the 1/2 plus 1/2, because it's the same base, so we can add our powers. 1/2 plus 1/2 is 1, so we could just say it's just 7. Or what we could do is rewrite both of these as a radical. So it's power over index. So here we have a radical sign. Our radicand 7, our power is 1, our index 2, so it's the square root of 7 times the square root of 7. Since they both have the same index, we can go ahead and multiply these two together. So then it will be the square root of 49, and then the square root of 49 is 7. So it does not matter how you do either one. But it just allows for you to look at a problem a little bit differently. In the future, there will be problems that you will need to convert to one or the other in order for you to solve. All right, that's it for this video.